So in the next 40-45 minutes, I will speak about how today's factories, production and manufacturing factories, could use a no-code, low-code solution like this Power Platform, which is, I believe, a really great solution for no-code, low-code solutions, and how they could use this for creating production floor monitoring, and especially how to create for some kind of IoT solutions. So first of all, after the nice introduction from Simon, who I am. So I'm speaking from Hungary, Budapest, capital city of Hungary. I'm working for a small consulting company called Fiscode. I've worked in many areas in software development in the last 20 years, but mostly focusing for BI, data warehouse, data lakes, etc. topics in the last 10 years. From the very first days, I'm working with Power BI, and nowadays, as Simon also mentioned, I'm a public speaker in Power BI, Power Platform, and signups topics. And just to comment Simon's thank you. I really liked this kind of sessions because every time I could show something else, which is not typical for a company day by day projects, rather just focusing some of my hobbies or pet projects, etc. And this whole session is also coming from one of my pet projects at home, and I would like to share my experiences from this pet project because I believe it could be useful not for home but also for companies. So nowadays, there are a lot of terms which are really important in this industry: the digital transformations of the company, the smart factory, smart manufacturing, Industry 4.0. In Europe, it is a really important phrase, or just saying that IoT, industrial IoT. So a lot of words, a lot of concept terms, buzzwords, but I believe they are really important because nowadays our companies, our manufacturing and producing companies and factories has a lot of information because they're not just having some machines and different devices in the factories, but rather we have a lot of sensors with special measuring devices which are sending the data to some kind of local environment, and then from the local environment they are sending the information to the cloud, and then in the cloud we could process this lot of data using machine learning algorithms. We could find anomalies, we could predict that a predictive maintenance should be executed or not, etc., etc. A lot of things could be done nowadays using the cloud, using all these data technologies. And it's really cool if you just think about in the automotive industry. The biggest automotive manufacturers all has a lot of robots, devices, and sensors, and they just would like to solve a lot of issues within the company, within the factory. It is called edge computing, and in the cloud also, which is the typical IoT scenarios. My idea was with this whole topic. It's coming from last Christmas, because in the Christmas I've got a gift from my wife and my son. It was a Raspberry Pi, and for the Raspberry Pi I just started to do a pet project, which is I would like to create some kind of device simulation. So there is humidity and temperature and maybe something else. I could simulate somehow that there are some machines in my company, in my factory, and I would like to push this information to the cloud and do some data analysis and some kind of other machine learning algorithms just to play with these technologies. And one of the first ideas was from me that maybe can I use the whole Power Platform, so the Power BI, Power Apps, Power Automate, maybe Power Virtual Agents for such a situation, or is it not the best technology for it? And I realized that, and my answer is that I believe for smaller IoT projects, yes, the Power Platform is really good. And then I just start to think that maybe not for big automotive industry companies like Audi, Mercedes, etc., but for smaller producing and smaller manufacturing companies who has just some CNC machines or 1-2 machines which produces items day by day, they could buy some devices and sensors and create some smaller IoT projects. But until now, they haven't started to invest such IoT projects because it is an expensive project. But using the Power Platform, I believe they could solve it because it is a no-code, low-code solution. So maybe one of the guy in the factory could learn it and start to do some smaller IoT projects. So that was my question, that Power Platform could be used for such scenarios or not. And I believe, yes, we could use it. So in the next 30 minutes, I will show some examples how it could be used for such scenarios. So we will simulate different devices. There will be 3 different machines, which will send the event messages notification to the Azure IoT Hub, which could ingest this data coming from the different devices from the factory. And then there will be 2 different approaches we called in the IoT scenarios passes, where we will check what kind of data arrives, process them, and if it is needed, we will make some actions because all this IoT scenario is needed for to have more better manufacturing or producing in our factory company. So there will be one approach which is called the hot pass. Hot pass means that we would like to process the data as soon as possible, and we would like to get insight from this processed data. And for example, if one of the message from one of the machine shows that the temperature of the machine is really high, I should create an alert and send an alert to one of the responsible people who could go to the machine and do what's needed to stop the machine or decrease the temperature of the machine in order to avoid any kind of breakdown of the machine and then a big loss for the company. So there will be one approach for us today is the hot pass. We will use the Power Automate for it. And the other pass, which is called in this IoT scenarios cold pass, is typically we would like to process the data as fast as possible, but it is not in the scope that it should be as soon as possible, because the goal with this cold pass that we would like to store the data. In this session, we will store the data into an Azure SQL database, but maybe in another bigger project, we could use a Synapse dedicated SQL pool, or just store the data at first in a data lake, and later we will upload to a curated layer in a SQL database or a dedicated SQL pool, or maybe it will be processed, brought into a Cosmos DB, whatever. The cold pass means that we store the data somewhere and later we could reuse, analyze and reuse this information. Maybe we will execute a complex machine learning algorithm to understand what kind of patterns in this data. Today we will just create a Power BI report, but not just a typical Power BI report like we will analyze the data over time and say that how many items are produced, what was the average temperature of the machine, so something like this. I would like to show something special. And the special is that if you go to a factory, a manufacturing, producing factory, you every time see a big LCD screens. And on the screens, there are numbers, KPIs that we produce, how many items, what is the speed of the machine, what is the temperature around the machine, what is the humidity around the machine. So several most important KPIs are available on these LCD panels. And I thought that maybe I could reproduce this kind of dashboards in a Power BI. So we will show how to create automatically refreshing Power BI reports. We will show this kind of information. And last but not least, we will create a Power Apps application to do some data manipulation. What kind of data manipulation you could imagine in this scenario? So typically, if you are ever been in a factory, you know that there are a lot of machines, people. So every time there is something happens, so you could imagine that one machine which was planned for today, for example, 500 items will be produced on this machine. Maybe we had to stop this machine and overheating or something problem happened. And now after 1 hour, we could use this machine again. And at the end of the day, the realistic is that we could produce 400 items on this machine. So typically somebody who is responsible for the production floor, a team lead, for example, during the day, maybe hour by hour, just refine the actual plan for today, and so he is refining the planned volumes for the day. So for such scenario, we will implement a small data manipulation application using Power Apps. So let's start. The first and very important thing, how to create such a situation, how to create such reports, or use the Power Platform to be able to check I could be a citizen IoT developer at home, or I could be a citizen IoT developer in a small factory where I would like to grab the data from the different devices and sensors and create some nice reports and do the hot pass to send alerts to the responsible people. How can I start such a situation and such a project? The first one that I also did last Christmas, that I've got a Raspberry Pi, like here, with keyboards, mouse, Raspberry Pi OS, and etc., etc., etc. Or maybe I just got Arduino or whatever sensors and other technologies and start to type Python or some kind of C++ programming language, learn what is MQTT protocol, how to connect to a cloud. So a lot of things, and I believe it is not the good way to start an IoT project, especially for a citizen developer, but also for a professional developer, because too many things you have to learn to start such a project. So then I just thought that maybe we should use, Microsoft has a great solution to do Raspberry Pi Azure IoT Simulator. So here you see the URL of this Raspberry Pi Azure IoT Simulator. It is a web-based simulator. You could do whatever you would like to simulate with a Raspberry Pi. You could write Python code, and the data could be uploaded to Azure IoT and then process, ingest, and also do all the stuffs. It's much better to start, but I have to say, because it needs some Python development, so maybe it is also not the best way to start, but it's much better to start, I believe. And finally, I realized that Microsoft has another great open source solution, absolutely free. It is called Azure IoT Device Simulation. Here is the URL. You could imagine that you go to this GitHub page. There is a step-by-step, very detailed instruction how to deploy this solution to your machine and to your Azure subscription. And after 10-15 minutes, you are able to create a nice environment where there will be a web page. And within 1 minute, I will show this web page. You could create as many machines and sensors as you like. You could define what kind of sensors and what kind of data could be sent from these sensors. And then you could start simulations with a lot of devices and machines. And all this data is automatically sending to your Azure subscriptions. And in Azure subscription, there will be an Azure IoT Hub which will ingest this data. And from that moment, you are good to go with your different IoT scenarios, or, for example, with our Power Platform solutions. So how it looks like in reality. I'm just showing, first of all, if I install this solution, I will see that there is a new resource group in my Azure subscription. And below this resource group, there will be a lot of new resources. For example, there will be an IoT hub which will ingest the data. There will be a virtual machine scale set, because in the background to generate these simulated devices and messages and sending all this stuff will be run on a virtual machine. There are some new items for having all the required network capabilities, load balancer, network security group, IP address, virtual network, etc. And finally, there will be a web page and app service which will help to execute this kind of simulation. So let's check how it looks like. It is not the most fancy application, but really useful to create such pet projects. I believe it is a really good solution. So this application called, as I mentioned earlier, Azure Iot Device Simulation, it's absolutely free. And there are only two screens on this application. One is that what kind of device is available for you. And the second one, using these devices, you are able to start simulations. I just would like to show one of there are a lot of built-in devices just to be able to start the project without doing anything. But I just created one of my devices, which is a floor machine number 1. And in this machine, there are 3 sensors which could generate temperature data, humidity data, and how many items are produced on this machine. And you are able to say that how to generate this kind of data. So for example, temperature is just a random number between 20 and 50 Celsius. Or humidity is random number between 20 and 70%. But for how many items are produced today is typically an incremental behavior. So first item produced, second item produced, third item produced. So you are able to do this kind of specification. And now we have one device. Then you could define another machine and another machine. And then you can go and say that I would like to create a new simulation. First, you say that the name of the simulation is this. And then just go here, select which kind of devices I would like to add to this simulation. For example, I just use only the 4 machine number 1, and maybe I would like to have 5 similar machines in this floor simulation, and I would like to generate messages every 10 seconds. This is the minimal interval that could use this simulator. And then which will be the IoT hub which will ingest these messages, and then you could start the simulation. Previously, I just created a modern factory simulation with 3 different devices. Every device generates different sensor data. The first machine generates every 10 seconds a message, the second every 15 seconds, the third machine generates messages every 20 seconds. And if I just click on this button here and say that start simulation, now in the background, first the virtual machine is warming up. It takes some seconds, not too much, takes some seconds. And then within 15-20 seconds, you will start to ingest the data and get the messages. Okay. So let's start to speak how to implement this hot path. So when you know that as soon as possible, we would like to process the ingested data and check that the message doesn't show a temperature which is too high for us, for example, or something else. And then if it is too high, the temperature, then we would like to send an alert to a responsible people. For such scenario, the IoT hub should be somehow connected to the Power Automate, because in Power Automate we could ingest, we could process this message and do a condition that if the temperature is higher than this Celsius degrees, then we could send an alert. For this situation, I will use a so-called Azure Event Grid technology, which is nothing else, just a very robust very scalable event receiver, event sending service in the Azure. As I remember, in 1 month, you could send 100,000 events for free. So to start a smaller IoT project, it is nearly free, or very small cost will be at the end of the month. The first step to use this event grid that we should somehow connect this event grid with the IoT hub. To do this, you have to go at first to the Azure subscription, and as you see on my screen, you have to check that event grid is registered to be a resource provider. If not, then you should register it. So one click, and then later you are able to assign the event grid to the IoT hub. But because the event grid itself doesn't have a built-in monitoring stuff, it is a bit hard to show that something is happening. So Ferenc is just speaking about event grid, but how can I check that the events, the messages are arrived to this event grid? So there is another great free open source solution for Microsoft. I just add also the URL here. It is again a GitHub solution. Azure Event Grid Viewer. It takes around 2-3 minutes to install this grid viewer, which again web application in the Azure, and it will show you that what kind of events are arrived to the event grid, and you could check that everything is fine, so it's good to go. So I just would like to show how it looks like, this event grid, because you remember some minutes ago I just started this simulation. You see that a lot of messages arrived in the meantime. So I just click here, and you see that one of the telemetry data which is coming from one of the devices is this, which is a JSON file. It has temperature data, how many pieces generated, what is the humidity, etc., etc. So this information is now arrived to the event grid. And because the data is arrived to the event grid, we will be able to process them using the Power Automate. But one step is that I would like to show before it, how the event grid is connected to the IoT hub. It's very simple. In the IoT hub, there is a section called events, and you have to click on the event subscription. You have to say that you have an event grid for this IoT hub. Just fill what kind of events you would like to subscribe. For example, you would like to grab events like a new device is created, a new device is created, a device is updated, a device is removed. Or for our project, I believe the most important one is the messages that is arriving from the sensors. So I just focus on the so-called device telemetry data. So then you are able to create a Power Automate alert mechanism. So let's check how to create a flow in Power Automate, which will get the data from this event grid. And for example, hot flow, it will be the name. Then event you see that there is something which has to trigger this flow, this Power Automate flow. And there is one triggering is when a resource event occurs in an Azure event grid. Okay, then I have to say that which subscription, this is my Azure subscription, what kind of resource should be done, IoT hub should be used in the event grid, which IoT hub should be used. I have only one at this moment. And what kind of event coming from this IoT hub should be checked, for example, the device telemetry information. And now I've got immediately messages, events that is coming from the event grid into the Power Automate. The next step is that in this event, as you saw, it is a JSON file. The body is a JSON file, so the temperature, the humidity, and all this information is coming in a JSON file. So first of all, I have to parse this JSON file to be able to handle this information. First, I have to say that which data which is coming from this event grid should be parsed as a JSON, the body should be. And then I have to add what kind of JSON schema is available in this body, because it is not so easy to know from scratch what kind of data is available. I'm just coming back to this event grid viewer, copy paste an existing data like this one, go here and say that I have a sample. Hopefully everything will be done. I just click here, and from this sample JSON file, he created the schema instead of typing from scratch by me. Okay, now we parse the JSON file. Now we could say that I would like to have a condition. In the condition, what is my goal? If the temperature is greater or equal than, for example, I just write a very small number, 25 Celsius degrees, then I should create an alert. In a real project, of course, we will write a much higher number, but to show you that it is working, I just would like to show that a very small number here. So if there is a threshold exceeded, so this 25 Celsius degrees, then I would like to send an alert. And for example, the responsible people will be me. I just say that, oh, it is an alert email, hot temperature. And then you could add that what was the date for this event. Maybe this is the creation time. What was the machine which generated this problem? This is the device ID. And what was the temperature, for example, at that moment, and which generated this alert. And you could say this was the temperature, and this is the temperature unit, the Celsius degrees. And that's all. I'm just coming down, save, and now I have a flow which could get the data from the event grid, check this conditional thing, and generates event alerts as an email to me and sending to me if there are some items which has temperature over 20. And hopefully I'm just trying to show it in reality. Maybe within some seconds there will be some new alerts. Yes, I'm just coming one. This is the date. This is the machine as a global unifier agreed, and the temperature here, which is another, and you see another alerts are arriving because I entered a very small temperature number just to be able to show very quickly how the alerts are receiving. So using this hotpath, we are able to process the data which is coming from the simulated devices, arriving to the IoT hub. The ingested data is go to the event grid, and from the event grid, Power Automate is able to process and check and send alert if it's needed. So within some seconds, we are able to send the email alert to the responsible people in our factory. So I believe it's really cool, and as you see, it doesn't need too much professional implementation. You have to know, of course, the basic items in an Azure IoT, that there is an IoT hub, event grid, and you have to, of course, know the Power Automate, but you don't have to write long codes. We don't know anything about what are the different protocols, etc. So I believe it's really cool. The other way that I would like to show is the call path. It was that we will store somewhere the data which is coming from the devices, and then we will start to analyze this data. For this session, I just stored the data in an Azure SQL database. Like here, previously I created an Azure SQL database with a device data table, and in this table I just store which device, how many pieces are created, what was the temperature, humidity, etc., etc. Then I created an Azure Stream Analytics jobs, and it's better to show it in reality. So what is this Stream Analytics things? I'm just starting this job because it takes around 1 minute to start stream analytics jobs, and until it is just forming, I will show you what is it, and you will see again that it doesn't need too much professional development skills. It's very simple thing, but it's a really good technology for such scenarios. So what is the stream analytics? You could imagine it is a tube. The tube has an input part where the messages from the IoT hub is arriving. In the tube, you are able to do some transformation. We will do a very, very simple transformation only in this session. And then at the end of the on the tube, there is the output. So what kind of output service you would like to use? For our service, for our session, we will use an Azure SQL database. So here you could say that what kind of inputs are available for the stream analytics. This is an Azure IoT hub. And what kind of outputs are available. For this session, I just created an Azure SQL database, but previously I just checked also that in a Synapse dedicated SQL pool, you are able to also to do this stream analytics job. And what is this job? I understand the data is coming from IoT, then we will write into an Azure SQL database, but what will happen in this Azure SQL stream analytics? So you could imagine, I just try to show it a bit bigger. So the data is arriving from the IoT hub like this: temperature unit, humidity, and the last item is the IoT hub. And in the IoT hub, there are additional information: what was the device ID, when this happened, etc., etc. And from this data, I am able to transform it to another data. So I have to write a SQL which is not a full SQL, but lots of SQL items are possible to use. So I just write a SQL, select from the input IoT hub. The result should be goes to the Azure SQL output, and I just selected some of the columns from the input stream and says that the input stream has this IoT hub with a lot of information in a record. I just select only one item, the connection device ID as a device ID. And if I just execute this test query, you will see that it transforms the data which as input stream, which is coming from the IoT hub, and generates something else which could be written into an Azure SQL database. If everything is fine, I just would like to show that this, because this Azure Stream Analytics job is executed, a lot of items, a lot of messages now are available in this database, because originally, previously, earlier I just deleted everything. Now we have several messages that is stored, and if this stream analytics job is running and running, there will be more and more and more messages in the SQL table. Okay, so we are able that all the machines will be, and all messages from the different messages ingested in IoT hub, streamed and write into a SQL database. So now all the information now in a SQL database, so we are able to process them, somehow analyze this information. So I just created a nice Power BI report, which is called floor monitoring report. And as you see, every 5 seconds, this Power BI report is updated, refreshed, because it uses a technology called automatic page refreshing. It is a technology which is released last year in Power BI. You have to select the page itself, and in the format panel, the last section is this page refreshing. You have to first enable it, and then you have to say that what kind of technology you would like to use for this page refreshing. There are 2 approaches. One is that you use a fixed interval, like here I am just using every 5 seconds. I'm trying to connect to the Azure SQL database and grab the data from the Azure SQL database. Here I would like to emphasize that this technology, this automatic page refreshing using the DirectQuery, because DirectQuery connection could ensures that the data is always the latest data. The other way to use this automatic page refreshing technology is that you are able to write a measure in DEX, which will say that the data is changed on the data source side, and you don't have to every time load the data from the Azure SQL to the Power BI every 5 seconds, for example, in our case. Rather, a measure could find out that you should do something, or the data which is arrived last time, it is also good. For our small project, I believe this 5 seconds automatic refreshing time is really good. And as you see, every 10 seconds, the machine one is arrived a message and says that a new item produced. On the machine two, every 15 seconds generated, and on the machine third, every 20 seconds generated that something happened. And you see, this is a temperature over time thing which is automatically updated due to this automatic page refresh technology. So sounds really good. We just checked this Power BI report. Now we are able to create such an automatically refreshing report, which could be visible on a big LCD screen in the factory wall, and everybody could see what is happening in the production floor. Cool. The next thing that I promised to you, that there will be a data manipulation application which will be implemented in Power Apps, because this daily refining of the planned volumes. So I've just created, using the Power Platform, another component, Power Apps, a small data application. It is not a very complicated application, I have to say. So I've got only one data source, this Azure SQL database. This Azure SQL database has another table which contains planned volumes. So it would say that on this machine, on that day, I have to produce this and these volumes. And this data is visible, as you see, on a data table here. And when I select something on this data table, it will be visible in this small modification area. The only value that I could modify the planned volume, and then I could click on the Save button. I just would like to show that how the Save button works. So when I click on the Save button in Power Apps, it means that every object has a property and event handler, and one of the event handler is the onSelect. OnSelect means you click on the button. And if you click on the button, you will see that we will update this table in the SQL database. I just found which machine data should be updated, and then store the value from that input editor. So nothing special. As I remember, it was 10-15 minutes with all the design work to create this Power Apps application. Then I just published this application, shared with my colleagues, etc. So from that moment, a responsible people on the floor is able to modify the planned volumes for that day, based on the actuals, based on the knowledge that this machine was bad, or these people is sick now, or something happened, so I just modify the planned data. But I believe for a factory where there are so many problems and so many tasks to produce and manufacture items, the most important thing is not our Power Apps application or Power BI report or another application and another application. Rather, the responsible people, this team lead people and the production floor needs one place, one hub where he is able to check the KPIs in a Power BI report, do the planned volumes, etc., etc. So the next step, I believe, in this code path is to integrate the Power Apps application into this Power BI report. Instead of having apps in a browser, a report in another browser, that we are able to have one place where all the important things are available for these responsible people. So how it looks like in a Power BI, I just created another page, a report page in the Power BI, and add a Power Apps visual to this page, and this Power Apps visual referring to this previously implemented Power Apps application. If everything is fine, then it should show the data in this visual. But really simple thing, it is just connecting to the Power Apps application, grabs the data and show the same screen that is available in your browser application, in your Power Apps application. Now it is embedded into Power BI. Okay, and then after it is done, the only thing that could be questioned and asked that, okay, everything looks nice. There is a nice Power BI report. There is an embedded Power Apps application. Okay, but it is in Power BI desktop. Is it possible to publish this Power BI desktop file to the cloud? What will happen? I need premium capacity or not? And the answer that this whole automatic page refreshing technology works fine with the shared capacity. So you could, for example, publish it to a My Workspace or any workspace which not assigned to a dedicated capacity. The only limitation is that the minimal interval to refresh the data is 30 minutes. So for our situation, it is not good, but there could be situations where every 30 minutes automatically refreshing a report page is absolutely enough. For example, if a complex process could generate an item only every 1 hour, then it's absolutely good for you to use a shared capacity for your report. If you would like to use something like this 5 seconds refresh time, then you need a dedicated capacity. So for example, my sample is using a PPU license. PPU is the premium per license. If somebody doesn't know it, what does it mean? It is now in preview and will be in general availability from 2nd of April. It is a user per user license to access all the premium functionalities. For example, if there is a company with only 10 people who are using Power BI, create reports or consume reports, but they need some of the, or maybe all of the premium functionalities, and they don't want to spend to purchase a very expensive premium dedicated capacity. From 2nd of April, they will be able to buy PPU licenses with very cheap monthly rate. So if you use this PPU license or you have a premium dedicated capacity or an embedded capacity, you are able to set up this automatic refresh. For example, here I just set up for 5 seconds, and then the same data is shown and automatically refreshed in this report. For example, you see that I'm just waiting some seconds and the data is refreshing. So in the browser, in the Power BI service, this automatic page refreshing is also working. And also the plan volumes are possible to check that. For example, on the machine one, for the 400 items are planned, but I see that today we are good to go with 500 pieces to create. Then I could update it, coming back to the dashboard, and you see that now on the machine one, we have 500 pieces for that day. So we are really good at this moment. So back to the presentation. My conclusion is that for our small pet projects or in a smaller factory which would like to use some kind of smaller IoT scenario, Power Platform with Power BI, Power Automate, and Power Apps, maybe with Virtual Agent, could be a useful solution. So I could say that the Power Platform loves this kind of industrial, factorial IoT solutions. So thank you for coming to this session, and thank you that hearing me, watching me. And if you have any questions now or later, there are email and social media accesses for myself. So thank you for having me, and